Hello everybody, this is Wayne Campbell. This video is a demonstration of the program that I've been writing called Decode. For those of you that don't know what this program is, it is written in BASIC 09 for the Tandy Color Computer 3. It will not run on a 1 or 2 because it's too big. But its design is to allow you to use an iCode module to recover source code, something that was never available for BASIC 09 before. I've been developing this program since 1991 in various incarnations and forms and with stops and starts along the way. The current version of Decode is 1.2.10. So I'm going to be showing you how to use this program and what it does. It is not finished. It is still in development, but it is finished enough that if you have a simple program, you can recover the source code from the iCode module successfully. If it is a more complex program, if it has complex type statements and record variables, there may be some difficulties. For the purposes of this test, I am only going to be using a simple program that does not have any complex variables. So to begin, you can see I'm at the DOS prompt. This is the VCC 2.01b emulator that emulates the Color Computer 3. So you type DOS to boot Nitros 9, and away we go. I created a test directory for doing my work in this program, so I'm going to CD to that directory, and I called it decode test. You look in the folder or the directory, and there is a single file called DELF. Stands for delete files. If you list it, it's a batch file. Oops. Might help if I specify the file name. You can see that it contains the delete command and various file names. At this point, these files do not exist in this directory. After I run decode, they will exist. And after I show you their contents, I will be deleting the files because I will be running decode multiple times in order to show you various aspects of the program. So, with that said, we're going to begin by running setups, which is the option setting program that allows you to specify your custom options. Now, you'll notice that I have the options set to give me a cayenne foreground and a black background. I've heard from many people over the years that they don't really care for the black background. So, if you press C, you can get the Colors tab. If you press F, you get the Files tab. V is the Views tab that you got when you first ran the program. So I'm going to come over to Colors, and I'm going to press, if you look at the bottom, you'll see Save and Exit, Defaults, and Exit. If you press S, you will save any changes that you've made and exit setups. If you want to exit without saving, you press E. If you want to reset to the defaults, you press D. So I'm going to press D and reset us back to the default settings for the program. And these are what they are. Under Files, you see that all of the files are on, which means that they are ready to be created by the program. If you decide you don't want to print out a file, using the right and left arrow keys, you can turn the file on or off. If it's off, it will not be output. If it's on, it will be created and output to the current data directory. Now, everything in Decode works with the current data directory, which means that if you want to decode a file by file name, the file must exist in the current data directory. If it is not in the current data directory, then you have to specify it by file list or path list. So anyway, over to the Views menu. You see that the default is display options at startup being on, which means that when you run decode, the options dialog will be displayed, and you can double check the settings you have or make any changes you want to make prior to continuing with that session. If you turn off display options at startup and you've run setups from within decode, turning it off will not have an impact on that session. It will be the next session that you will notice that it didn't pop up when you started decode. Now, on processes, you notice the first two files are on by, or the first two windows are on by default. These are all windows. And what these windows will display to you is described by the name. Now, if you want to just very quickly not display any windows this time, but you don't want to change the settings, then you just turn processes off. All of the windows between instruction decode and DSAT validation will be ignored during this run and until you run setups again and turn it back on. The source output item is not whether or not you're going to get an output. This merely opens a window that lets you see the source output while it's working. The output file will be created no matter what, because the whole point and object of this program is to give you your source code. So that file will be generated and output no matter what. It does not exist in the Files tab because there is no option for turning it off. Back to Views again. You can turn processes off and nothing will be displayed. Conversely, you can turn processes on and turn everything else off, and none of the windows will be displayed. The primary reason for the processes on-off is just for for this one time, or not necessarily for this one time, but until you change it again, you don't have to worry about seeing all those windows, or any of those windows. They will not occur if processes is turned off, making it a one-switch setting, instead of requiring you to go and turn off every window you had turned on. So back over to colors. Foreground and background color for the window are based on the window. You'll notice I'm using the term window, which is black text on a green background, and hence that's what the defaults are. When you run CreateDB, it will check the window to see what its foreground and background colors are, and then store those values in the initdb file. So if your window, for example, if you're using W1 and you've got it set to an 80-column window with a blue background, a blue foreground, and a white background, then this will be blue and white instead of black and green. For these two, the background overlay, middle overlay, and three, background overlay, middle overlay, and foreground overlay, the only ones that you will notice a difference in the options dialog is foreground overlay and background overlay. Background overlay will not necessarily change while you have setups open this time. It will change the next time you run setups. The foreground overlay will change instantly, and I'll show you an example of that. Let's say I want to have my other settings of a cayenne foreground. You see that it changes it immediately. And then a black background. And it changes it immediately. Okay. For the background overlay, you'll see that it doesn't really change. Let's say I decide I want to change it to magenta text on a red background. Now you notice it didn't change. Even if I go to a different window, the background overlay still remains yellow on blue. And the reason for this is because that change won't take place until after you save the file and then run setops again. Okay. When you exit setops, if you do a save and exit, this will be saved, and as decode continues through its processing, any windows you have displayed will show these colors. Again, I'm setting it back to defaults because I want the first run to be what you're going to see if you don't change anything from the default settings. So I'm going to press S for save and exit, and that sets our defaults for setups. Now, I'm going to run decode, and I'm going to decompile a module called JD. I wrote a program recently that was posted in the Cocoa mail list that determines Julian day. I called the module JD. So I am going to use that as the test module for showing you how decode works. Now, JD is in the current execution directory. I did not write decode so that you could specify -X to get to the current execution directory. So you have to specify the path list. In this case, it'll be decode /DD/CMDS/JD. Running program, here's your options. You notice it's popped up because display options at startup was turned on. Colors are the default colors and the files are the default file settings. So I will press E for exit because I'm not changing anything, and decode begins. Now, I'm going to let it run, but as I go through I will show you this. This information is what's contained in JD_raw.txt. You'll notice on the bottom here, variable references are enclosed in curly braces, line references in parentheses, and literal references in square brackets. Now you're going to say, well, what about all those angle brackets? Well, the angle brackets are the tokens and what the tokens mean. For example, 45 is the then token. Okay. 90 is the quote token for the beginning of a string literal, etc. All of this information can be found in the structure of iCode on Cocopedia. So you can look up what all these things are there. Anyway, as this continues, you'll notice that it gets to the end of it and it says press enter to continue. That's included there because at some point you might want to be trying to study something in it. And you can always use Control-W to pause the output while you study it. Now, these two numbers here are the module offset from the beginning of the module and the execution offset from the beginning of the iCode area. Okay. The vertical bar separates the addresses from the actual instruction. The instructions are laid out in the order in which they occur in the iCode. Now, you will notice that the instructions are not the way you would write the code in text. For example, 820081 represents an integer variable. Colon equals is the assignment operator specified by token 52. If you use just an equal sign, the token is 53. 8D is a byte literal. The value is 0. CB is float to the top of the stack, and then 3F0L. What that does is, because it's being used in a way in which it will be dealt with as a real number at some point. Oh, no, that's not right. No, that moves it to the top of the stack. So anyway, you can tell by these what they are. For example, 8F is a real literal. The value is 365.25. Okay. 55, IVGT. This is called an invisible goto. And believe it or not, that is what the basic 09 header to the original source code calls it. Invisible goto. So having a copy of that header, I have used it to help me identify a number of things that would have otherwise been unidentifiable in terms of what to call them. So it helped a lot. So anyway, you can see how the code is laid out. Now I will press enter. It shows that the file is done, and it goes to the next part, which is the variable references list, which is also line references and literal declarations. This is variable declarations. This is variable field declarations for type statements. These are keywords that begin a statement and how many times they occur in the file. These, from byte down through hex, are literal declarations. You can see that there were 45 byte literals, 4 integer literals, 5 real literals, 23 string literals, and no hex literals. Now, else down to go sub are line references, and the only two that are line number references is go to and go sub. Else, end while, end loop all have line references that are actually just offsets in the code. With an else statement, if you do an if then else end if, then if the statement or if the expression in the if then test is true, every instruction between if then and else is executed, and when it reaches the else statement, it retrieves the address to jump to, that is the first instruction immediately following the end if token. With end while, it is the address or the offset of the beginning of the first instruction within the while loop. With end loop, it is the beginning of the first instruction within the loop structure. With go to and go sub, it is an actual line number reference. You'll notice that there are 2 go subs in this program. Down here, we have the invisible go-tos and other line references. I call them 55-1 and 55-2 because each one of these serves a slightly different purpose. In this context, it's like in the if-then test, where if the statement evaluates to false in an if-then else end if, it jumps down to end if, or to else, and then the first instruction past else, and executes every instruction down to end if. If it's if then end if, then it points to the first instruction after the end if. In the on expression go sub statements, the invisible go to actually points to the next instruction after that. Okay. The 3B version, which there are 2 versions, the first one occurs in restore and then statements when you specify a line number. And so therefore it is the reference to the line number, and in the I-code it's the offset address within the I-code area of where to jump to. In on expression go to go sub, the line numbers that you specify separated by commas are each represented by a 3B and an integer value that is the offset of the address to jump to. The offset address to jump to. Now, following this are the for next information. 2 and step have values 46 and 47 for their tokens. If the for next is an integer loop, meaning that the variable used in the for statement is an integer, then if there is a 2-step with no, or a 2 value with no step value, there is a byte value that has the value 0, 0. If there's a step value, that value is 0, 1. With a real for next, the without step is 0, 2, and with step is 83, or 0, 3. And that's what this is about, because in a for and next statement, these 2 items here actually represent unidentified variable addresses. For example, let's say you have a for next loop that says for I equals 1 to 10. And I is dimensioned as an integer variable. The value will be 0, 0 because there's no step value. If because it's an integer, then the address of the integer will be there. It will be, because it's an integer, it'll be 81 followed by an integer value that is the location in the data memory where that variable begins. Because it's an integer, it occupies 2 bytes. In the to field is another integer value following the 46 that represents the next variable location after the integer specified in the for statement. Right? Meaning that it's, for example, if the integer value is shown to be at memory location 01D2, then this 2 value will be at 01D4. Right? If there's a step value, that's a third offset, and that one will occur immediately after the 2 value, and in our example would be 01D6, each of them occupying 2 bytes. In a real version, each one of them is 5 bytes because a real uses 5 bytes to store its value. So that is the explanation of what all this is about. And you can see there were 14 byte variables references, 22 integer variable references, 24 real variable references, 8 Boolean variable references, 5 string variable references. And here comes the interesting part. It shows one record of the 85 type. Well, that's not exactly true because 85 and F2 can represent any of these and any of these. In this particular instance, 85 and F2 are, and I'm not sure, I have to look at the I code, but it's either representing this vector array or it's representing one or more of these. Okay? And since there's only one occurrence, I'm assuming it's probably the vector array. Now, for those that don't understand the terms vector, table, and matrix, in the OS 9 68000 version 2.4 Microware Basic Manual, Microware identified one-dimensional arrays as vector arrays, two-dimensional arrays as table arrays, and three-dimensional arrays as matrix arrays. I have borrowed those terms and used them because they are much easier to say and take up much less room than one-dimensional, two-dimensional, and three-dimensional. This is also covered in the structure of iCode, so you can refer to that page to get this information and understand what each of these things are. Now, I press Enter to continue, and it comes back to here. Now, all the other windows are turned off. So I'm going to use this opportunity to explain this screen. Project is the name of the file or the path list that you specified on the command line. Start time is, okay, I'll have to wait. This is your source code being output to this window and simultaneously being written to the jd.bo9 file. You'll notice that it looks more like actual Basic 09 source code. The difference being that all of these over here are the variable names, and the simple truth is they don't look like the variable names you would give something. Well, I followed a simple convention that's also used in disasm. If you can't give it actual variable names, then you give it generic variable names. So each one of these represents a variable specified by the first letter being the type, B for byte, I for integer, R for real, L for Boolean, S for string, C for record, because of the name complex. Originally, the Basic 09 manual referred to them as complex type variables. So I used the letter C to represent complex, and R was already being used for real. field variable, and these are all uppercase letters. If there was a record variable, the fields would be lowercase letters. So it would be a lowercase b for a byte field, lowercase I for an integer field, lowercase r for a real field, lowercase l for a Boolean field, lowercase s for a string field, lowercase c for a record field. Okay? And for the arrays, simply an A is added. So in the example of the string array in this file, its variable name is SA, followed by the integer value. Now, the other convention I followed is that on variable names, it's a 4-digit number, and they're not hex, they are decimal. In the case of a field, it would be a lowercase r. If this was a field variable, it would be a lowercase r with 1 0 and 1 6 instead of 2 zeros and 1 6. So that's just for reference. This program doesn't have records and fields, so you don't see any of that. When it's done, you press enter to continue. The program ends. Now you'll notice that I put the cursor up here and printed total time and then gave you your prompt back here. The reason is this is the last line of the program. I wanted you to be able to see the data as it accumulated, especially if you have windows popping open, you don't get to watch all this. So I wanted you to be able to see what it found in the way that it's displayed on the screen. So I'm going to give you the explanations now. The start time is determined at the time decode begins its process. The module name is taken from the module header, and then all of these items in here is the module header data, except for this, and the module CRC. The module CRC is the last 3 bytes of the file, or of the module, and the total program variables is an integer value that occurs between the definition area, which I call the DSAT, and the symbol table, which I call the VDT. And it is the total number of variables defined, including to and step variables, and any variables defined by use that were not dimensioned in the original source code. And another thing that this program does is it does not know, there is no way to tell the difference in I code between variables that were dimensioned by use and variables that were dimensioned by dim statement. So all variables in the output are given dim statements. Right? So that would be another way you would know the difference between your program and the decode output, is because anything that you dimension by use would now have a dim statement. And that's actually a useful tool because sometimes you misspell a word for a variable name and end up creating a variable that's not the variable you want. And unless it's something that's constantly being used, you may not even see the bug. Okay? Well, decode will help you figure that out when you're looking at it and going, I don't remember having 3 real variables. I only remember having 2. So you look for that variable in the instructions and you find out that it's supposed to be an integer. But you must have misspelled your variable name because it got dimensioned by use as a real. And that's one way you can correct some of your mistakes when you get your source code back. And not just get it when you get it back, but you can use decode as a debugging tool. You can run it and compare the output to your source code to see if everything's the way it should be. So to continue, this is the actual work area. And all of these things are very important and they all mean something. Total is the grand total. In terms of line references and variable references, it means the exact number of references found. Okay? Which means anytime a particular variable was used again, it counts as another instance. Valid and unique apply to line refs and variable refs. The valid is line references. In the case of JD, there is only one line number, 10. There are 2 references to that line number, and they're both go subs. So you can see it found 15 line references, but only 1 valid. Now, you might say, well, wait a minute, you said you only had 2 go subs. How come there's 15 line references? Because of the if-then tests and anything else in there that used invisible go-tos. Okay. Now, on variable references, 83 references were found, but only 20 were unique, meaning they were individual variables, where many of these 83s were the same variables occurring over and over and over. Terminators, backslash and EOL. The reason I count the backslash as a terminator is because even though it is the instruction stacking operator, so that you can put more than one instruction on a single line, the truth is that most programmers only use it to put a comment on the line after the instruction. And in that regard, it serves as a line terminator, because when you pack the code, the comment and the EOL are not included. It's only the 3E, which is the backslash terminator. In this program, there are 2 of them, and they are both comments at the end of a line. EOL is the end of line terminator. It's the hex 3F. There were 74 of them found. Okay. 74 and 2 is 76, which is the total number of instructions. Okay. For the VDT, or the symbol table, it's the number of entries found in that table. For the DSAT, it's the number of entries found in that table, which is also called the definition area. The DMA is the data memory allocation. I have not yet written the code to validate the DMA, and that's why there's nothing on that line. I'm still dealing with issues with the DSAT and record variables and type statements, trying to figure out how to get those to be some semblance of correct. But I may go ahead and do the data memory allocation code simply because it's not required to have the DSAT completely validated and have all type and variable type and complex variable statements rectified. I have enough information in the variables file to be able to validate the DMA. So I may go ahead and do that code, but I haven't done it yet. Now over here under action, this is if you were seeing it at all, and I'm going to run it again with no windows so you can see what goes on over here. This tells you what it's doing. When it gets to the end of the last action for that part, it prints the time that it took to complete it. Now that time will include however long if you have one of the windows opening, however long you left that window open before you pressed enter. So because I was talking so much when that window was open, it took 3 minutes and 11 seconds to finish the instruction part. The line numbers part took 13 seconds to identify them, sort them, number them, and write them out to the file. The variable references took 2 seconds to sort them, name them, and write them out to the file. On the VDT and the DSAT, the last thing you will see over here is either validated or not validated, and the amount of time it took. In this case, they both validated. It took less than a second to validate the VDT, to completely do the VDT, and about a second, maybe a little over, to validate the DSAT. The total time of the program was 14 minutes and 4 seconds. Now, I'm going to show you in the directory, all of the files got created. So I'm going to turn T-mode pause on so that you can see what the output looks like. What? Oh, equals, not plus. Okay, list JD raw dot So you can see that this is the output that was being written to that window that was open in the instruction decode. So if you want to, that's why you don't have to worry so much about that window. You've got this to go by if you want to study the output. Next we have the JD lines. Oops. And that's what's there. You'll notice there's only one line number reference, and it's given the line number 10. And you'll notice there were two references. Those were both of the Go substatements. Now, JD vars is the variable references. This is not going to make much sense to you until you understand what it's doing, and I'd have to change the page size for you to be able to see the beginning of the file and see what the names of the columns are. But I can give you a brief overview. This is the number of the variable in this as it occurs in this list. The first one being number 1, the last one being number 20. This is the variable type token. This is the memory offset where it occurs in the data memory allocation. Now here's where we can determine what 85 represented. Okay, according to this, it represented a string, right? And that string is the this is the parameter string. Right? The parameter string was the date that you passed, or the file path that you passed to it. You'll notice here 82006D is a real variable that's R0010. It's 5 bytes long and it occurs at 006D in the data memory allocation. So you see, that's how this works. Then list. VDT text. This is the VDT list, or the symbol table list. There's only two entries. One is the parameter string. The other is the string array that contains the weekday names. Okay. The DSAT, or definition area, contains 3 entries. The first one is a 10-character string. The second one is a 10-character string. And the third one is the string array. And they all validated, and there was no unidentified gaps in the DSAT. Unidentified gaps occur when there's a type statement. I have to go through that to give you a better understanding of what it's finding and why I'm having difficulties with it, which I will do at some other point. But for right now, this is what's in the DSAT file. And then last but not least, is the JDB09 file, which is the source code. Here you go. It is there. Now, because I don't have the page size set smaller, I have to do this. Oh, wow. Okay, there's something wrong. It did not print out the dim statements, and I don't know why. I guess I have another bug to fix, folks. It was working fine. I guess when I fixed a display bug, I screwed something up there. So I will have to fix that. So anyway, mode U equals 0 to turn the pause off. And then I will run delf to delete files. And that is your basic default version of decode. Now, I am going to get to that dim statement problem and find out why it didn't print it. I will be looking at that a little later today, but for right now I want to continue with the with what I'm doing here to show you decode. So I'm going to run setops again. This time I'm going to change the colors. Oh, and on the colors menu, foreground colors are popped up using the right arrow key, and background colors are selected using the left arrow key to show the menu. Then you use the up and down arrows until that little marker there is on top of the color or beside the color that you want. Then you press enter to select it. Okay, then down arrow to get the background, left arrow to open that menu, and I'm going to make it the black background. Then I'm going to do the same thing. I have to figure out why that's doing that. Open up the foreground. And open up the background. Black. There. Now, I'm going to demonstrate processes being turned off and no windows being displayed by simply turning processes off. I'm also going to turn off display options at startup so that you don't see it. I'm going to leave all files on. So back to there, and then save and exit. Now decode /dv/cmds/jp. And here we go. And I'm just going to let this run so you can see how it does everything without opening any windows and how the information on the screen is updated. In some of these cases on the side over here, the things that it does may go by so quickly that you don't notice it. That's okay. The decode displays file on the unpack decode page on Cocoa Coding describes everything that gets displayed on the screen and what it means. So you can refer to that document in order to understand what's going on this screen. Now you'll notice that the file names are being displayed at the bottom line of the screen, so you can tell when they're being written. When they get done, it says done, and then moves on to the next part. Now I did have to put a little delay in there for it to say done long enough for you to actually read it. So I did that, and I'm hoping that this is acceptable and adequate for those people that like to have an idea of what the program's doing. That was the primary reason for this display to begin with, because I personally can't stand a program that sits there and you don't know if it's doing anything or not, because the cursor's not moving, there's no indication that anything's being done, and as in the case of disasm and a larger module, you can be waiting for 20 minutes before it starts putting out any code at all, and you have to wonder sometimes, did it get hung up? Did it freeze? Right? Did it get stuck in a loop? Yeah, because there is nothing to tell you what it's doing. This allows you to be able to look at it and go, oh, okay, that's where it is. That's what I like. That's what I want, and I'm hoping that other programmers feel the same way, that they like to know where the program is, okay, so that they can tell whether it's hung up or not. So as you can see, it only took 59 seconds for the instructions to be decoded. The overall time will be just a little over 2 minutes. I've decoded this module many times now. So, and one thing I am going to look at is the output to, you notice that the program set your background and foreground colors for the screen back to their default colors. It does not clear the screen in order to turn the whole screen black on green, because I want this information to be available for you to look at if you want to study it. What I would like to be able to do is, once I set the colors back, is to change the screen buffer so that what's black turns green and what's cayenne turns black, so that everything is still there. It's just in the appropriate colors for the screen. I don't know how to do this. I don't know if it's even possible to do it on a color computer. If it is possible and can be done, I would appreciate someone giving me some assistance on how to do that. Anyway, we look in the directory, all the files are there. Now, I'm going to list JDB09 because I want to see if the dim statements are there in this run. No, they're not. So I screwed something up somewhere and ended up making it where it's not outputting the dim statements. So I have to fix that. Okay? That's sad. I did not want there to be an issue. I thought I had everything fixed. It's okay. I will get that fixed probably sometime today. For right now, I want to continue with this demonstration. So, once again, I run Delft to get rid of the files. And the next thing I'm going to do is change the options again. I'm going to turn processes on and turn the other files off. And I'm actually going to turn source output off. I'm also going to go to files and I'm going to turn off all the other files so that the only file output is the source code file. And colors are still good. I think I'm going to, just for the purposes of demonstration, the middle overlay does not apply to this dialog. And the reason is because of the tabs. The current tab is white with blue letters. Background tabs are yellow with red letters. And I wanted to keep it that way, so I made sure that the middle overlay did not apply to the setops dialog. Okay? But I am going to change the background ones and middle ones so you can see what they look like with different colors in decode. And the next time I run setops, you will notice that the background overlay that says that is blue background and says options at the top and save and exit, defaults and exit at the bottom will be the colors that I specify now. So I'm going to change it, the foreground color to magenta. And I'm going to change the background color to red. It's going to look kind of weird, I think. I don't know that magenta on red looks that good, but it'll give you a clue of what you can do. For the middle overlay, I'm going to change the foreground color to white, and I'm going to change the background color to blue. Now I'm going to save and exit. Now decode /cd/cds/jd. Oh, you're not going to see any windows because I turned them all off. Anyway, this is to prove that turning processes off will stop the windows from being displayed, even though you've got a couple of them set to be on. So I'll just let it run through until it gets done. And because I'm not opening the output window this time for the source code output, I am going to check the JD file once again to see if the source code includes the dim statements. I'm not certain that it will. I'm pretty sure that it's not going to, but I want to be certain so that I know what I'm looking at when I go in to try to correct it. Well, not try to correct it, but when I go in to correct it. It's obviously, to me, not going to be a difficult fix. It will be simple enough. It's just a matter of I changed something and made it to where it doesn't know that the output file is open and that it's supposed to be writing the dim statements. So I will fix that and get it back to where it's supposed to be. And when that happens, I will post on the mail list. And perhaps I'll upload a newer, shorter video that just demonstrates the fact that the output is now corrected. So, I hope everything I'm saying up to this point is making sense and is explaining things to you in a way that helps you. If you feel that my explanations are not quite adequate, please let me know. I would like to be able to make sure that anything I'm explaining is understandable and acceptable. So if there's something vague in what I'm saying or it's not quite clear, please let me know so I can try to improve how I describe and explain things. Should be just about done with the source code. Okay, here. JDB09 is the only file there. 09, and yep, no dim statements, so I have to fix that. Anyway, so now let's do this again, setups. And I'm going to turn displays back on. Now you see, the background overlay is now magenta on red. Turn those back on and turn that back on. I'll leave those off. And I'm going to leave the background overlay the way it is so you can see it looking what it looks like in decode with windows open. So save and exit. Instead of retyping it, I'm just going to find it in the list. There we go. Here we go. See, the background overlay is now magenta on red. The middle overlay is now white on blue. The foreground overlay is still cayenne on black. So the whole point of this was to allow you options. Now what I originally wanted to do was to give you 16 colors, 8 brighter colors and 8 darker colors. Because the way it's set up, you can select either of those color menus for either option. It's not a requirement that you open the foreground picker for the foreground color or the background picker for the background color. But because both pickers are the exact same 8 colors, it doesn't really matter which one you use. So foreground for foreground, background for background. It actually saddened me to learn that you are not allowed 16 colors in text mode on a color computer. You're only allowed 8. And that really saddened me because I really wanted to give you 16 colors the same way that you could have 16 colors on a DOS machine. Okay? So that you could have, for example, a dark blue background and a bright yellow foreground, so that the yellow stood out more. Okay? So that you could have a black background and a bright blue foreground that stood out more, and something like that. So unfortunately, I cannot give you that because it won't allow you in text mode to display more than 8 colors. So if I set the background picker to darker colors, every time you set one, it would change the palette. Okay? And for example, let's say using blue. If I change the background picker to be a darker blue, then anything that was foreground color of the lighter blue would then become a darker blue, and there's nothing you could do about it. It's unfortunate. I really think that that should be rethought. OS 9 or Nitros 9 should be rewritten to allow you to have 16 colors if it's at all possible to do that. And I'm not saying it is possible. I'm certain those people that know more about it than I do will probably hand me a list the length of your arm of reasons why you can't do that. Well, if you can't do it, you can't do it. Okay? I can't argue with that. But it's a nice wish. Yes, I'm definitely going to have to fix that. So now you see by changing the colors, you can have different colors in your overlays. Colors. Change this back to yellow. Change this back to blue. Okay, so that concludes this test and demonstration of decode. I hope you found it interesting and educational. Leave comments below, and you can also post messages on the Cocoa list if you have access to the list. You can always join the list by going to maltedmedia.com and choosing to join the Cocoa list. Thank you for watching this video. If you like it, give me a thumbs up. If you don't like it, well, I would rather not see any thumbs downs, but if you absolutely have to, go ahead. And again, leave comments. And I appreciate everyone watching this video, and I hope to be able to bring you more quality videos in the future. Thank you.